Hello everyone. In this module, we are going to learn about immunization. So basically, we are going to talk about three things: dedication, retinal immunization, and full immunization. So each one has its own differences from one another. So we'll go through each topic. So all of this really begin from this topic, interest rate sensitivity. Because of that, we have to come up with these strategies. Otherwise, at very beginning, if there's no, everything is fixed, then we really don't need any of these immunization strategies. So most financial institutions try to insulate their portfolios from interest rate risk movement. So what they're trying to do, they're trying to insulate their portfolio from interest rate risk movement. So that's basically what's the sensitivity to interest rate. So some institutions, such as banks, are concerned with protecting their current net worth against interest rate movement. So other, like pension fund, may face obligation to make payments after given number of years. So when you have money, this kind of organization, they cannot just forget about their obligation. They have to always think about what are the obligation, when they are, what time they have to meet that obligation. So the time also very critical on this decision. So um, time to, let's say, pay, for example, in pension fund, pay pension. Okay. So at that time, if you don't have money, even though you have enough assets to cover all the liabilities, you are in trouble. Okay. So just saying assets more than liabilities not actually enough. Um, you have to think about whether you can liquidate that asset when the time come to pay the liability. Sometimes, let's say your asset is a home, okay, and then you have to pay like cash loan. Let's say tomorrow, can you liquidate your home to cover that loan? Yes, home value may be more than cash loan value, but this one is very it takes some time. It's illiquid, so liquidity is going to be a problem. So the institution need to think about timing of this obligation. Otherwise, they are in trouble, even though they have more asset than liability. Okay. So these institutions are more concerned with protecting future values of their portfolio. So when the interest rate go up and down, their portfolio values go up and down. So they really have to think. So let's say your rate goes from I goes from let's say 10% to 20%. Okay. Then the bond value, if you're holding bond as your asset, then the bond is going to be decreased. So if earlier you had like 10 million, maybe now it's like 5 million. Okay. So that if that happened, you are in big trouble. So if what if this happened within one day, like a steep decline within one day? So institutions need to really protect their future value of their portfolio. Otherwise, they are going to be bankrupt. The common factor amongst different investor and financial institutions is the presence of interest rate risk because net worth fluctuates with interest rate. Financial institutions try to structure their asset and liability in such a way that they are protected against small change in interest rates. So if you have really big changes, maybe it will be very hard to protect, but small change you should be able to protect. Okay, you cannot complain against small changes. Insurance companies collect premium from their customers and then invest these premium, and these premium and interest earn on them insurance company asset. Okay, so that's what they do. Okay, so you collect a premium and then you invest. But once you get the premium, you have obligation. For example, if it's a life insurance, then you have obligation to pay the death benefit. If it is annuity, then you have obligation to pay the annuity payments. So the company need to be careful, and they have to invest and to get the income of that. So the assets are used to pay claims as they occur. The claims are liabilities. So insurance company are required to make sure that assets are matched to the liabilities to assure that cash will be available to pay claims as they occur. So it's not like assets equal liability, okay? It's also timing. This is not the case, okay? It is more about timing and so many other things. So here you can see 3 strategies we are going to learn in this FM class: dedication, immunization, and full immunization. Immunization without full party, it's called as Reddington immunization. So let's go to the first one, dedication. Dedication or absolute matching. In this section, we discuss an approach for matching liability and asset. So it's called the dedication or absolute matching. In this approach, and company structure and asset portfolio in such a fashion that the cash inflow will be generated from asset will exactly match to the cash outflow from liabilities. Okay. So this is basically also, you have to think about the time too. Okay. If the above strategy is achieved, the company has full protection against any movement in interest rate. So if you can do that, then you are protected against any kind of interest rate. So the problem in dedication is, first, cash flows are usually not that predictable on either asset or liability side. Okay, so that's going to be a problem because you have to match. Okay, not just liability. You have to match cash outflow to cash inflow. That's not predictable. Okay. Then if the liabilities are long-term in nature, then it might be impossible to find assets to exactly match the liability without creating reinvestment risk. So basically, let's say you have liability in 30 years to pay 100 million. Then you have to find an asset which will give you 100 million in 30 years. Can you do that? Maybe it's not that easy. So finding that that kind of matching asset to liability is not easy. The yield rate on funds structured with major restriction imposed by absolute matching may be less than that on fund for which flexibility is available. And the extra return may overshadow the advantage of absolute matching importance. Okay, so so when you do this, maybe you could have earned extra yield if you're more flexible than this. So that flexibility is gone. Okay, and then also I want to mention that the return rate on asset is not equal to usually return rate on liability. I mean the interest rate on the liability. So those rates also going to be different. So you have to be careful with that too. So here's you can see a example, and let's try to do this problem. An insurance company accept an obligation to pay 10,000 at the end of each year for 2 years. The insurance company purchase a combination of the following 2 bonds, both with 1,000 par and redemption value, in order to exactly match its obligation. So bond A, 1 year 5% annual coupon bond with yield rate 6%. Bond 2, 2 year 8% annual coupon bond with yield rate of 7%. So find the number of each bond the insurer must purchase to exactly match its obligation. And then find the total cost to insure purchasing the need of number of bonds. So so this kind of problems, it may take some time to fully solve the problem, okay, because it has sort of steps. So the step 1, let's try to understand the obligations. Okay, so you have 2 years. So here is the obligation. So what's the obligation? 10,000 at the end of each year for 2 years. So then so this is obligation. So the insurance company purchase a combination of following 2 bonds. So so we are going to buy 2 types of bond. One is 1 year 5% annual coupon bond with yield rate 6%. So this one look like one. Right, for the timeline at the end of the year. So what's the coupon amount? It is if it is face value is 1,000, you get 1,050. Okay, so so anyway, so it would be face value, because par value and redemption value both are same, 1,000. Okay, so this would be F plus FR. Okay. Let me write FA, because that would say the face value of bond A. Let me write this way, plus 1,000 and 1,000. So FR is 1,000 times 5%. So plus 50. Okay. So for the bond B, you have, it's a 2-year bond. So it would be 0, 1, 2. And here you get 8% coupon, so $80. And then here you get 80 plus 1,000. Okay. So find the numbers of each bond the insurer must purchase. So if you buy one bond, then of bond B, then at the end of the year 2, you have 1,080 in your hand, but you need 10,000 to your obligation 10,000. So let's say number of bond B purchased. Let's say it's XB. So then XB time 1,080, because that's what you are going to get for per bond, should be equal to 10,000. So that would give us how many bonds we need from bond type B. So it would be 10,000 divided by 1,080. That's going to be 9.25 and 92592. Okay. So now so let's say you are going to buy from type A, XA. So then you can see the, because you have 80 in here from bond B. Okay, so how many bonds you have? XB. So XB time 80 plus XA time 1,050 should be equal to the first year obligation, 10,000. So this one we already know, because we need 9.25 to match the second year obligation, which is 10,000. Okay. So this allows you to solve for XA. So let's try to solve it. Divide by 1050, I get XA as 8.8183421. Okay. So this is number of bonds you need, okay? Not the price, number of bonds. So so in here, each bond the insurer must pay. So you can say from type A, you have to write 8.81. Now you may ask, how am I going to buy this fraction? Yes, you can do that. Okay. If you're a large investor, you have mean and method to do that. So then find the total cost of the insurer. So now we need to know the price. So let's first calculate the price of bond A. Which is basically present value of this payment. Let me write price A, which is 1,050 discounted at rate 6%. So 1.06 to the negative 1. Okay. So that's giving me what? So that's giving me 990.5660. Then what about the bond B? So now you have discount this one and then this one. Okay, so you have 80 discount at rate 7, and then 1,080 divide again at rate 7, but you have to use that. So you would get, let's see. So you would get 80 times 1.07 to the power negative 1 plus 1080 times 1.07 to the power negative 2. So the price is basically 1018 and 080182. So this would be the second one. This would be the first price. Okay. So total price now what? For bond A, you had to pay $990, but then how many you are going to buy? You are going to buy 8.8 now. So XA time price A plus XB time price B. So it would be 8.81 times 990.566 plus XB is 9.25, 2592 times 1018.08. So you get the answer. So that's how you, so now you are sure that at the end of the year 2, you have 10,000 from bond 2, bond B. From end of year 1, a combination of bond A and B give you 10,000. So you match your obligation to the assets. And there's no problem because you know for sure you're going to get, unless the bond issuer become default. That's the different question. Okay, so you can still see still there's a risk because you are really depending on the bond issuer now, creditworthiness. So here is another question. This one says a company must pay liabilities of 2,000 and 3,000 at the end of year 1 and 2, respectively. The only investment available to the company following 2 zero coupon bonds. So 1 and 2. So these are zero coupon bonds. So there's no payment in, no cash flows in middle. So here you get 1,000 plus the coupon amount. The no coupon, zero coupon. 1,000. And then here, the person would get 1,000. So the liability wise, you can see 0, 1, and 2. Liability wise is 2,000 and 3,000. So you can see, of course, you have to match because there's no cash flow coming from the zero coupon bonds. You have to match the year 2 obligation to the 2-year zero coupon bond, year 1 obligation to the 1-year zero coupon bond. So you need how many bonds you need from type 2. So let's say it's X2. So then X2 time, you are going to get 1,000. That should match to the liability, which is 3,000. So X2 is basically 3. Yes. This is the number of 2-year zero coupon bond you need. Then the number of 1-year coupon bond you need, let's say it's X1. X1 time, at the end you get 1,000. And then it should match to the liability, which is 2,000. So X1 is 2. Okay. So now you know how many, the number of coupon bonds you need, zero coupon bonds, 1 year and 2 year. Now we can find the price. So what's the price of 1 year zero coupon bond? It's 1,000. So 1 year zero coupon bond. So price 1,000 times you have discount. Okay, so let me say that's going to be so this should be 952.38. And then for the other one, it's 1,000, but 2 year, and the rate is 6%. So that's give you 809,996. So the cost, total cost would be X1 times P1 plus X2 times P2, because this is number of, and this is price. So X1 is 2 times 952. X2 is 3 times 99.996. Okay. So that gives you the total cost. So I'm going to skip this SOA problem because I think you get the idea. You can try these problems, these 2 problems, and see whether you can do it. If not, please ask from me. Now, the next topic is Reddington immunization. So the previous one is dedication. Basically, you dedicate assets to liability. You are exactly matching. Okay. So at the end of the when the time to obligation come, when you have to pay, when you have satisfy that obligation, you have the money coming from assets because you match exactly to the exactly to that time. Okay, so in this case, you can see that. So at the end of the year one, you have 1,000 because you have zero coupon bonds. End of two, I mean the $2,000. End of year two, you have $3,000 because you match you have zero coupon bond to make sure that you get the money. Okay, so now it's a bit different. So you can see still you have cash, but the approach is different. Okay? Reddington immunization. So immunization is a technique that has been developed to structure the assets and liability in a manner that will reduce or even eliminate problem caused by changing interest rate. In other words, the enterprise would be immunized against the adverse effect created by changing the level of interest rate. So we are going to discuss this in our next video. You will learn a lot of new, you will learn a new approach under this topic, the immunization.